Okay, welcome everyone back to today's class. Today we are done with the boring part of the chapter number 1, which was binary and information representation. And today we are going to be discussing the more interesting part, especially starting off with the ASCII table. ASCII table. All right. So basically, before this, we studied what binary is, right? We learned about what registers are, how we store data, and stuff like that. But today, we are going to be studying the system of how do we store text in a computer system. Like we always write these sentences A, B, C, D, E, F. Let's say, hello, my name is Maaz. But how does a computer get to know what does H represent, what does M represent, what does Z represent? The system behind this is basically known as ASCII. ASCII is basically this is an abbreviation of American Standard Code for Information Interchange. This was introduced in 1963. These are just basic information. You don't need to memorize this, but just for your own understanding. And what does this mean? It basically includes all the characters which we use. What do I mean by that? Wait, let me get the space up. So the standard ASCII system includes a character set. A character set. And what's a character set? A character set is basically, it's like you could say a database where you have all the characters defined, where you have all the characters. We use basically char, char to represent a character in computer science. Characters are defined. So in this database, we tell that, let's say if we press A, like on a computer, it's more of like if we press key number 1, let's say key number 1 represents the A on your keyboard, then you need to type A. Key number 2 should type B and stuff like that. This is basically how a computer understands what you are trying to type. So we have a database where we have already defined the buttons. My bad, straight line. Like A is button number 1, B is button number 2, C is button number 3, D is, let's say, 4. And then based upon that, we are making our own sentences and stuff like that. Now, character set basically includes 127 bits. This is important. Let's write this up here. Character set includes 7-bit codes. 7-bit codes. And due to it having 7-bit codes, this means that the maximum it could store is 128 bits or 0 to 127. In denary, 0 to 127 in denary, or 0 to 7F, as mentioned earlier, that like this is in terms of hexadecimal. Like 128 could be maximum represent 127 could be maximum written as 7F in hexadecimal. So your character set or the ASCII table set has 7 bits. This is something you need to memorize. This is an important thing. And what do we mean by 7 bits? 7 bits mean, sorry, not 128, my bad. 7 bits basically mean that we could maximum store a data of 127 in denary and 7F in hexadecimal. Now you just need to know the denary part. This hexa part isn't that important, but if you want to memorize, it's up to you. But now what does this mean? This basically means that we have specified, as mentioned earlier, some specific functions. And those functions are written in, what do we call it, hexadecimal. Now let me share this picture with you and then you all would get what I want to say. Just a minute. Let me get, just let me take the screenshot, new, and yeah. Okay, paste it up here. Let's move it down. So yeah, this table has been mentioned there in your book. What did I mean by 0 to 127? This means that ASCII character system can maximum represent 127 elements. So under the ASCII table, we have 127 separate elements, each representing a separate thing. Like let's say the number 32, this represents the character space or if we want to discuss it in hexadecimal, then the hexadecimal value 20 represents a space. Then number 33 represents this exclamation mark. Likewise, number 40 represents the open bracket from left side. Then we have number 49, which represents the character 1. Then we have, let's say, 72, which represents a h. And then on the other hand, we have 104, which represents a smaller or lowercase h. So just like this, the ASCII table has been defined in a manner where we have told that each denary digit represents a specific sort of element. And you need to memorize, not like you shouldn't memorize, but it's not something necessary. But if you can memorize this, I would highly suggest this. From denary, in terms of denary, if you guys want to write it, just go write it. In terms of denary, if you move from number 65 to number 90, this represents uppercase A to uppercase Z. In your A levels, you should be knowing that 65 is uppercase A. And why do we know, why should we know this? Because sometimes there is a question, how are we going to write a capital C in ASCII table, or what would be the denary value of capital C from the ASCII table? So if you know 65 is A, then 66 would be basically B, and 67 would be C. And if you even see it up here, 67 is a C. And that's the concept basically behind this. This is for the uppercase one, and for the lowercase one, again in denary, for the lowercase one, it starts at 97 and goes up to 122. This is from lowercase a to lowercase z. These are some things you should be knowing. Now, after this, there is a small change in the ASCII table. The computers which you use nowadays, they do not include ASCII. Like the ASCII is an older concept. We now have a new thing, a new number system, which is known as Unicode. What is Unicode? Unicode is just like ASCII. It's like a number system, a database where we could store these tables. But the difference between ASCII and Unicode is that Unicode was introduced due to some disadvantages of ASCII. And those disadvantages were that ASCII could maximum represent 127 elements, due to which we couldn't store other languages or other symbols in it. Like nowadays, if you see, we not only have English, we have Urdu, we have Arabic, we have all sorts of keyboards representing all these languages. But if you only see, we said that if we mention the special characters followed by the uppercase one and followed by the lowercase one, we reach the maximum capacity of 127. Now, where are we going to be storing these languages or other type of stuff? For that, we need to come up with a new type of system which has much more space, right? And that system is basically known as Unicode. Unicode has the first 128 elements. Like, let's erase this and let's make up some space, just a minute. And then we could, just a minute, remove all this. Yes, so Unicode has the first 128 elements of the same ASCII table. This means that you have the standard English letters already covered. These 128 elements basically cover the English letters and the special characters. Special characters include stuff like @ symbol, exclamation mark, let's say open quotation marks, apostrophes, and stuff like that. These come under the first 128 elements and the special characters. Now, why was the Unicode published? It was basically published for several reasons. One was to create a universal standard which covered all the languages. All the languages. Another reason for this was that yes, the other reason behind this was to create a more efficient system. And what do I mean by more efficient system? By more efficient, I mean that we have a single system which could represent everything. You see, previously ASCII was only representing English, right? ASCII was only representing English. And if we wanted to, let's say, represent Urdu, then we had to come up with a new number system, let's say keyboard number 2, or a new system, Pakistan keyboard system, let's say, for example. And that Pakistan keyboard system could only represent Urdu. Now, the benefit of Unicode is that we could represent everything under a single number system, due to which we have made it like much more efficient. Okay, so yes, just a minute. The first 128 characters are the same, and apart from that, there is a small difference which I need to confirm before sharing with you guys. That was in O levels, and it's not mentioned in the A levels book, but wait, there it was up here. Okay, yes. A question sometimes come up which says that what's the difference between ASCII and Unicode? Wait, let's go down and let me check. There is a question sometime which says difference between ASCII and Unicode. The main difference between ASCII and Unicode is that firstly, Unicode represents all languages. This is basically a 2-mark question which used to get tested in O level, and we are not sure if it could come in A level. But yeah, there is a probability the examiner could test you on whatever thing they want to ask. And so Unicode represents all languages, including special characters, whereas ASCII only represents English, and the first and the special characters. This is point number 1, and this would get you 1 mark. 1 mark. The second point is basically Unicode takes up to or supports up to 4 bytes per character. Unicode supports up to 4 bytes per character. Wait, I would explain what do I mean by this. Whereas ASCII takes 1 byte. Basically, by the term 4 bytes per character, 4 bytes per character, I want to say that if we are using a single slot, that could represent or take 4 bytes. And due to this reason, we are able to like represent a greater number of languages. Like previously, if we only had 128 elements, now we could store, and these 128 elements each took 1 byte. Now, each of this 128 element would be taking up to 4 bytes. This means we could store up to 4 times more data. Also, this Unicode is, wait, let me confirm it on Google too, just a second, is Unicode. Because this was mentioned in the O-level book, and as you are here without your O-level background, I would confirm it for you. Is Unicode 16-bit? Okay, yes. Unicode is basically 16-bit system. And by it being 16-bit system, I mean that it could maximum store 2 raised to power 16 bits, whereas the standard ASCII could only store 2 raised to power 7 bits. So you see, we have a big difference up here, 216 and 27. There's a big difference in between this. And due to this reason, we could store much more data. Okay, and apart from that, there is sometimes a question. Why does Unicode occupy more space? The reason behind that is it supports up to 4 bytes per character. So if a question comes up, why is Unicode taking up more space? Taking up more space. then you need to write just one statement that Unicode supports up to 4 bits per character, whereas ASCII takes a single byte, 1 byte. So the more the bytes, the more data there. Yes, exactly. 100%. You see, it's basically you missed the first class. The reason behind that is 2 raised to power 7 means that there are, let's say, 7 columns in this. And 2 raised to power 16, on the other hand, this is just a basic example, but you should go through the first class and you would get what I wanted to convey up here. 2 raised to power 16, on the other hand, could mean you having up to 16 more bits of like 16. Uh, that's not the proper explanation, but it's just for your own understanding that 2 raised to power 16 means that you have 16 sections. And each of those 16 sections, let's say we have 128 maximum up here. In 2 raised to power 16, we have a maximum of, wait, 2 raised to power 16. Yes, we have 65,536. So we on one side we have 128 and on the other side we have 65,536. So you see, the greater the number of bits, the more data we could store. And if in the future, let's say we need a much greater system, a system where the Unicode is also inefficient, let's say, assuming, then we would be shifting towards 32 bits. As told in the previous class, if you remember, I said that IPv4 is 8 bits or 16 bit, whatever I said, I believe it was 8 bits. And then IPv6 is 16 bits. Why did I say this? Basically, from this, I tried to convey the message that the larger the number of bits, the more possible data you could store. And so even by now, if there is space in Unicode system, we could replace it with, let's say, a new character. If I introduce a character like this, and I assign it a value such as this should represent M, then Unicode would be able to do it because it would have space. And let's say if we don't have space and then we have special characters coming up, then at that case, we would be moving towards a new number system, much better than Unicode. Now, there is also one other number system which I missed previously, and that was extended ASCII. Extended ASCII. Extended ASCII is basically the same original ASCII, but if you remember, we said that original ASCII is of 7 bits. The catch here is that extended ASCII is of 8 bits. And due to it being 8 bits, it could now store up to 256 elements. All of the other things are exactly same. If a question comes up saying that what's the difference between extended ASCII and the plain ASCII, just tell that extended ASCII has 8 bits, whereas the original ASCII has 7 bits, which allows extended ASCII to store more elements. But this was introduced when we saw that ASCII, the original one, didn't have enough space. But still, the extended ASCII resulted in inefficiency because we weren't able to store key characters of other languages. And just to make sure that we are storing those of the key important stuff, we came up with Unicode. That's all for the Unicode number system. So how do we store data? A question comes up in A level. This is pretty common, and I would highly encourage everyone to memorize this. How does a computer store data? Computer store data. Okay, so sometimes the book doesn't mention such details. These are stuff you learn when you are doing past papers. And so for a question like this, how does computer store data? You need to, it is usually 2 to 3 mark question, okay? You need to first tell that each character is assigned a value, is assigned a value. Okay, just this sentence. Each character is assigned a value in the computer. In the computer. Then each character is assigned a value in the computer. In the brackets, you could say binary equivalent. And then you need to talk that when we basically type those characters, This isn't the exact one, but it's just to clarify the concept. Later on, I would be sharing a document which has those keywords of examiners. So you would get the ideal or the perfect definition in that context. Let me see what the exact one is for this one. If I could find it, just give me a second. I had a document up here with me, and let me see if I could open it. Just a minute. And I would be sharing it soon with you guys for paper one. It has a lot of important stuff mentioned in it. And so, yes, where is it? Just a minute. Mm, yes, all of the characters said, okay. Each, yes. Here we have the perfect keywords. The first point is that each character has a unique code or is assigned a specific value. Then, when we type a character, type a character, type a character, it is replaced by its corresponding code, corresponding code. And lastly, these codes are stored in the same order as in as in the word. What do I mean by this? Let's say, consider a scenario where we have specified that A is 55 and Z is, let's say, 90. And I write this code AAZZ. How does a computer get to know what do we mean by AAZZ? So we have firstly assigned an individual value to A. Then we type in the code. The computer processes it in a manner that it checks what is the value of A. Okay, A is 55. So we get 55, 55, 90, 90. This representing Z, this representing Z, this representing A, and this representing A. And later on, the computer knows that if we get the value 55, sorry, on the screen, print A. So when we transform or execute this function, we get A up here, then A again for this, then 90, Z, then Z again. And that's the main concept of how we store the data. Pretty simple. Um, Apart from that, a common, perhaps let me make a small diagram which explains the entire process in simple words. We have ASCII, which uses 7 bits. Then we have extended ASCII, which uses 8 bits. And finally, we have the Unicode, which uses 16 bits. And that's the only concept you guys need to know. They could ask you questions like, what's the difference between extended ASCII and Unicode? And how are you going to be telling that? You need to say that each represents a specific character using a Unicode. Let's say if they are asking a similarity. Yeah, we have a similarity among them too. Let's write it up here. Each character is assigned a value. This is a similarity. You see, it's a similarity between them. Is assigned a value. And what's the difference? This is using 16 bits, extended one is using 8 bits, and the simple ASCII is using 7 bits. And one other difference is that Unicode can represent all or maybe multiple languages with much more characters, multiple languages, whereas the other two couldn't do that. Okay, that's the entire ASCII table concept. It's pretty simple, and I believe you guys understood what I tried to say about this. Are there any questions regarding ASCII? Or yeah, sure. Ask off. Questions, question time, question time. Next, after this, we would be shifting towards chapter 1.2. We are done with chapter 1.1 till here. Yes, wait, you didn't take the first class. Let me explain this in the right context. So 2 raised to power 16 means that you could maximum represent 65,536 elements. 2 raised to power 7 means that you could maximum represent 128 elements, because 128 is the number in denary. 2 raised to power 16 means that 65,536 elements could be used. And let's say 2 raised to power 8 on the other hand means that we could maximum represent 255 elements. It's basically 2 raised to power 16 minus 1. The computer gets it this way: 2 raised to power 7 minus 1, which makes this 127, and then 2 raised to power 2 raised to power 8 minus 1. This is how a computer gets it. Basically, it reduces one from each of these. You didn't take the first class, due to which you might get confused in this, but if you watch that, you would get to know. So yes, each element being one character, 100% correct. In this 65,536, the first 128 represent the same ASCII one, perhaps 128 ASCII one, and then from 128 up to 255, those represent the extra characters which were introduced in extended ASCII. And then after 256 to 65,536, this include all the other characters, so including the new languages and stuff like that. 100% correct. 65,535 characters can be represented in a Unicode. Yes. And let's say if we need more space, it would be two. Let's say the next one would be, obviously, we move like 2, 4, 8, 16. The next one would be 32. So if we wanted to come up with a number system which has even more data, then that would be 2 raised to power 32, which would store 32. That would be something like 42949679296, and so on, like 1 2 3 4 5 6 7 8 9 10, around 10 to 11 digits. Just imagine. But we don't need that much, because we have covered almost all of the characters till this very moment. But let's say if we need something like that, then obviously we would be shifting to that concept too. A new number system could be introduced, or before this we could also have something like extended Unicode, but we don't need that as of now, and this would be something, if ever required, this could come up in the future. But for now, in your course, you only need to know ASCII, and then extended ASCII, and then Unicode. Okay, so one other thing, your exam won't be testing you on how much data could a Unicode number system store, or how much data could an ASCII store. The key points which you need to know are that ASCII has 7 bits, and extended one has 8 bits, and then the Unicode has 16 bits. Bas. That's the max you need to know. Because 16 bits, 65,536, you don't have to memorize such data, but you just need to know it uses 16 bits, this uses 8 bits, this uses 7 bits. What are the key differences between them, and what are the key similarities between them? Once the chapter is over, I'm going to be sharing a document which has everything, those key terms or the key questions which you guys need to memorize. And once you do those, all these descriptive questions, like descriptive questions of 3 to 4 marks, you guys could easily ace them. I received that just before my exam, and if I had that before, I would have like memorized the whole stuff, and that was really really helpful, to be honest. Okay, so we are done with chapter number 1.1. Now we would be shifting to 1.2. I would be ending the meeting right now, because the class is just finishing, and I would be sharing the new link with you guys. Just join up, and then we would be starting 1.2. So if this is the YouTube recording and I'm stopping the video up here, then the next part would be uploaded soon. Do check out the playlist, it would be out there. And so for now, take care, and let me stop the recording.